Welcome to my presentation, everybody. I'm just going to go over the different bootcamp projects of Lighthouse Labs that I did in the previous year here. So let's just go through this. The first project that I did was this API project, and this was the structure. So I connected to a City Bikes API, imported libraries, used an endpoint, and created a network URL and got network ID information, connected to Foursquare and Yelp APIs, and then there were various points of interest, joined some data from part 1 of this Bikes API to part 2 of this, created a new data frame, then used data visualization to explore the data. I built a model, a regression model using Python stats modules that demonstrated a relationship between the number of bikes in a particular location and the characteristics of the points of interest in the location. Then I interpreted the results. So what were some of the data discoveries and insights? So basically, we looked at 3 APIs, Yelp, Foursquare, and City Bikes. Most data came from the Yelp API. Looked for bars, restaurants, and coffee shops in the top 10 restaurants. Looked at the different correlations between different variables, and the goals were to parse the data and also use EDA and regression and different APIs. So top 10 restaurants were listed here. We had the name, review count, rating, and price. And the more the euros, the higher the price, obviously. So this is what I got with their different IDs. And I put some box plots and plots showing histograms of different variables here. There was a histogram of free bikes. There was a heat map of the full data set over here. There was also the combined data set screenshot that just combined some of these columns over here. And then I had a OLS regression model with various results. The adjusted R squared was pretty small, it looks like. It only explains 0.7% of the variation of the data. So this model doesn't seem like it was a good fit. So very small value here. The F statistic, the p-value for the hypothesis test is greater than 0. So we failed to reject the null hypothesis. That's what we can see right here. The independent variables did not affect the dependent variables. We can also see that there's some coefficients, so that average POI price has the strongest positive impact on the number of bikes per station, whereas the rating has the largest negative impact on the number of bikes per station. So you can look at the different coefficient values for that. But p-value less than 0.5 is considered to be statistically significant. So we can see the regression output shows that all p-values are greater than 0.05. In other words, review count, rating, and price attributes of a point of interest do not impact the number of bikes in a bike station. There were some errors in this project with normalizing the data, couldn't find an API key and environment variable, the data was not defined. Combining data frames caused some errors or issues with JSON data types and extracting, and the API limit was reached, so I had to work around these issues. For the quality assurance process, I fixed missing values, fixed structural issues, removed irrelevant data, removed redundant data, and fixed data types and removed outliers. And then if I had more time, I would do more data cleaning. I would explore the Foursquare API and build a similar model and see what output I could get for the regression model compared to other cities and see what the overall data says with the API, conduct more SQL series assessments and answer more questions, then make a classification model. So that was the first project on APIs. The second one was on SQL. So the project flow for this one was loading CSV files into the database using pgadmin, importing CSV files and creating tables. I did some data cleaning, deleting null values, coalescing, converting data types. I started with questions, solving 5 questions, and then I had 3 questions I had to make up. I QA'd my data as before, did data validation, checked to see data integrity, and I generated a relationship diagram and loaded the final table into PostgreSQL database. Errors and challenges. So there were lots of errors importing tables. I deleted some of them because there was so much data and issues with that. And there were also issues with the data types of varchar, numeric, and text categories. And I had to manually write queries for an all sessions table, which basically imported this information in. So you can see these are all the different results of importing the different tables into PostgreSQL. Data discovery and insights. I showed the average number of product for each country city, so it could show what contributed to GDP. Saw the top selling product per country and city. Used the total revenue generated by each country and how much quantities they sold. So we can see some of our tables here is country, city, product category. Here we have a category count for each of the different product categories. Over here, we just have more information on the product name. So this is the version 2 product name. It's slightly different than the other tables we have here. QA process fixed missing values. They were not all able to be fixed in the data set. They weren't set or available, so that's something I had to consider. Fixed structural issues, which was trying to do joins between columns, and removed irrelevant data, like coalescing null with 0. And we also removed redundant data, fixed data types, and removed outliers. If I had more time, I would do more data cleaning, make a legend for the data set and table of values, maybe do more predictive analytics down the line, and see if we can connect it to other tables. So I will stop the video here and cover the other 2 projects in the next video. I hope you all enjoyed, and let me know if you found value in this. Thank you, and bye for now.